Hello viewers, we are going to discuss about sampling. The objectives of the lesson are to introduce basic terminology used in sampling, to understand the difference between population and sample, to differentiate between a parameter and statistics, to explain the nature of sampling and sampling error, to learn sampling designing process. Since I was mentioning in the objectives, the terminologies used in sampling must be understood by every researcher. There are certain technical terms like element or subject, which means one person, one participant or one case. Population, the entire class of subjects that are to be studied, example, species, voters, buyers and clients, etc. Sample is those subjects or participants actually selected from the population of the specific observation. Sample is those subjects about whom we have data that what we are going to analyze. Data are observable values of variables. Another important terminology is group. Group is a part of sample or a subsample. Population is the entire collection of objects which a study is interested in. Size of the population may be very large or very small. Sample is subset of objects drawn from the population of interest. Summaries of population data are called parameter. There is only one true value for each population parameter. These true values are usually unknown and can only be estimated. The values are expressed in terms of Greek alphabets. For population size, it is capital N. Population mean, it is mu. Population variance is sigma square. The summaries of sample data are called statistics. Statistics is the mathematics of the collection, organization and interpretation of numerical data. We can draw many different samples from the population. Unlike parameter, each sample gives different statistics and they are expressed in terms of alphabets. Sample size is expressed in small n, sample mean is expressed in capital M, sample variance is expressed in S square. Sample statistics are used to make inference about unknown population parameters. It depends on how the sample is drawn. A random sampling may be representative of the population. Let us now understand the nature of sampling. Sampling is the process of selecting a small number of elements from a larger defined target group of elements such that the information gathered from the small group will allow judgments to be made about the larger group. To know which is sampling and which is parameter, following questions will be clear for us. Who is the target group for the study? This is called the study population. Who is in the target group should be surveyed. This is called the sample. How many people should be surveyed? This is called sample size. How should the people be surveyed, be selected? This is called sampling method. What are the reasons for taking a sample? Practical considerations such as cost and population size, inability of researcher to analyze large quantities of data potentially generated by a census. Samples can produce sound results if proper rules are followed. In the process, we come across sampling error. Sampling error is any type of bias that is attributable to mistake in either drawing a sample or determining the sample size. Let us now discuss about sampling designing process. There are basic steps to be followed for sampling. Step 1, define the population. Step 2, determine the sampling frame. Step 3, select sampling techniques. Step 4, determine the sample size. And step 5, execute the sampling process. Let us now discuss in detail all the steps. Step 1. Define the target population. The target population is the collection of elements or objects that possess the information sought by the researcher and about which inferences are to be made. The target population should be defined in terms of elements, sampling units, extent and time. An element is the object about which or from which the information is desired. Example, the respondent. A sampling unit is an element or a unit containing the element that is available for selection at some stage of the sampling process. Extent refers to the geographical boundaries and time is the time period under consideration. So, this consists of step 1. In continuation of step 1, to define the population, there are certain important qualitative factors in determining the sample size. The importance of the decision, the nature of the research, the number of variables, the nature of analysis, sample sizes used in similar studies, incidence rates, completion rates, resource constraints. Now, in the process of sampling designing, we come to step 2. Step 2 of sampling designing process is to determine the sample frame. Sample frame is a master list of population from which the sample will be drawn. In this process, we also come across sample frame error, which occurs when certain elements of the population are accidentally omitted or not included in the list. Sample frame error refers to the degree to which the sample frame fails to account for all of the defined units in the population. For example, a telephone book listing does not contain unlisted numbers. It is difficult to get an accurate list. Now, we come to step 3 in the process of sampling design, that is sampling techniques. If you look at this slide, we have the various types of sampling techniques that I have listed here. You can see sampling techniques are categorized under 2: probability sampling techniques, non-probability sampling techniques. The probability sampling techniques are also known as random sampling techniques. Non-probability sampling techniques are known as non-random sampling techniques. Further, if you can see, probability sampling techniques are further categorized under simple random technique, systematic sampling, stratified sampling, cluster sampling. The non-probability sampling technique are further categorized as convenience sampling, quota sampling, purposive sampling and snowball sampling. Now, let us go into the details of sampling techniques. Probability sampling is also known as random sampling. Random samples are those in which each population element has an equal probability or a quantifiable probability of being selected. The 4 types of random sampling are simple random sampling, systematic sampling, stratified sampling and cluster sampling. Let us discuss in detail. Simple random sampling is a method of probability in which every unit has equal opportunity of being selected. Number 1, choosing the sample size. The larger the sample, the more accurate the generalizations that can be made about population from which the sample is drawn. Identification of each element. Each element is given a unique identifying code. Codes are selected randomly until all the elements in the potential samples are identified. Number 5, random selection can be done using a computer, a table of random numbers or a blind draw method. Next, we come to systematic random sampling, which is one of the probability sampling. Systematic random sampling is a method of probability sampling in which the defined target population is ordered and the sample is selected according to position using a skip interval. Following are steps involved in drawing a systematic random sample. Get a list of units that contains an acceptable frame of the target population. Determine the number of units in the list and the desired sample size, compute the skip interval, determine a random start point. Beginning at the start point, select the units by choosing each unit that corresponds to the skip interval. Now let us see an example of systematic random sampling. If the population size is 20 and the desired sample size is 5, the 20 cases are to be arranged in a systematic order in cyclical way as mentioned in the diagram. Then the skip interval is calculated by using a formula where the population size is divided by the desired sample size. Here population size is 20 divided by sample size 5 gives rise to 4, which is the skip interval. Start from a random start point among the 20, say for example 7. Next 7 plus 4, which is the skip interval, gives rise to 11 in the first case of the sample. Next 11 plus 4, which is the skip interval, gives rise to 15, which is the second case of sample. Next 15 plus 4 is 19, the third case of the sample. Likewise, you have to calculate from the cyclical counting after 19 with skip interval 4, that is 20, 1, 2, 3, and so 3 is the fourth sample. Next 3 plus 4 is 7, which is the fifth case of the sample. So 11, 15, 19, 3, 7 includes the total sample size of 5 from a population of 20. Now we talk about stratified sampling. Stratified sampling involves breaking the population into mutually exclusive subgroups or strata. Example, breaking the sample down on the basis of gender into male and female strata. Then to choose the sample from each stratum. Simple random sampling or systematic sampling may also be followed. There are two types of stratified sampling. One, proportionate sampling. Two, disproportionate sampling. Proportionate sampling, this is present when sampling from the strata reflects the proportion in the population. Example, an investigator wants to interview people who visit a psychologist in a counseling center. The investigator is aware that approximately 1/7 of the visitors to the center are female. Accordingly, if he wants a proportionate stratified sample, he has to sample in such a way as to get 6/7 men and 1/7 female. The disproportionate sampling, if the researcher does not require their sample to have proportions of the population, they can choose to have the sampling being disproportionate. In the above example, the researcher may take equal number of men and women. Now we come to cluster sampling, which is one of the probability sampling. Cluster sampling is a probability sampling method by which the population is divided into groups or clusters, any of which can be considered a representative sample. These clusters are mini populations and therefore are heterogeneous. Under this, we have systematic and area sampling are two common methods. How to draw an area sample? Divide the geographical area into subsectors and give them names or numbers. Determine how many sectors are to be sampled, typically a judgment call. Randomly select these sub-areas. Do either a census or a systematic draw within each area. Cluster sampling involves initially sampling on the basis of larger unit than the population element. This can be performed in one or two ways, in a single stage or a multi-stage. Single stage cluster sampling, if researcher wish to survey students studying psychology in India, instead of identifying all the psychology students in India, he identifies all the places where psychology courses are being run. He could randomly select a number of courses and then survey all the students on those courses. The multi-stage cluster sampling, if researcher wish to survey children at secondary school, identifying of all the educational institutions in the country, then there is a possibility of selecting randomly from them. Within the selected authorities, identifying all the schools and randomly select them from those schools, then surveying all the children in the selected schools or take random samples from each school that had been selected. Now let us discuss about non-probability or non-random sampling techniques. There are 4 types of non-random sampling techniques: accidental sampling, quota sampling, purposive sampling, and snowball sampling. Accident sampling is also known as opportunity or convenience sampling, sampling those people one happens to meet. Convenience sampling attempts to obtain a sample of convenient elements. Often, respondents are selected because they happen to be in the right place at the right time. There is a possibility of error that occurs in convenience sampling in the form of members of the population who are infrequent or non-users of that location, or who are not typical in the population. Example, a researcher stands outside a supermarket and approach as many people as are required. Judgmental sampling is a form of convenience sampling in which the population elements are selected based on the judgment of the researcher. Subjectivity enters in here, and certain members of the population will have a smaller or no chance of selection compared to others. The example is an expert witnesses used in court. We come to the second non-probability method, that is quota sampling. In quota sampling, the units are not selected at random, but in terms of certain number of units in each of a number of categories. Quota sampling is an opportunity sample, but with quotas set for the numbers of people from subsamples to be included. Example, researchers want an equal number of male and female cases. Once he has achieved his quota for one gender, he will approach only members of the other gender until they have sufficient cases. Sometimes the quota might be based on age, socioeconomic status, where it may be necessary to approach everyone and ask them a filter question to see if they are in one of the subgroups to be sampled. If quotas are being set on a number of dimensions, then the term dimensional sampling is used. We come to the third important non-probability sampling technique, that is purposive sampling. Purposive sampling is used when researcher wishes to study a clearly defined sample basing on the predefined inclusion and exclusion criteria. Snowball sampling is another important non-probability sampling. It is also referred as referral samples. Snowball sampling require respondents to provide the names of other respondents. This is one of the best methods for doing research on vulnerable population or hidden population. Let us be clear that the techniques we discussed till now have certain advantages as well as disadvantages. The researcher therefore should be careful while opting any specific technique for choosing sample from population. If a random sampling has been employed, it is possible to generalize the results obtained from the sample to the population with a certain degree of accuracy. If a non-random sample has been used, it is not possible to generalize the results to the population with an accuracy. It is pertinent to mention that many researchers nowadays prefer online sampling techniques. Here we are going to discuss 3 types of online sampling techniques. Random online intercept sampling, which refers as a random selection of website visitors. Second important sampling technique is invitation online sampling, is when potential respondents are alerted that may fill out a questionnaire that is hosted at a specific website. Online panel sampling is another important sampling technique, refers to consumer or other respondents panels that are set up by the marketing research companies for the explicit purpose of conducting online surveys with representative samples. We come to the step 4 of sampling designing process, that is sample size calculation. There are qualitative and statistical approaches adopted to determine sample size. As I had already mentioned in step 1 while defining the target population. However, I want to remind you again those qualitative factors which are important for determining the sample size. They are importance of the decision, the nature of research, the number of variables, the nature of analysis, sample sizes used in similar studies, incidence rates, resource constraints. In addition to these qualitative factors, statistical approaches is also followed to determine sample size. One of the most popular approaches is Cohen's approach. According to Cohen, in the year 1998, In order to perform a statistical power analysis, 5 factors need to be taken into consideration. 1. Significance level of criterion. Number 2. Effect size. Number 3. Desired power. Number 4. Estimated variance. Number 5. Sample size. If sample size is to be determined, it can be estimated for any given statistical test by specifying values for the other 4 factors. That is, significance level, effect size, desired power and estimated variance. To determine the sample size, Cohen's table may be referred. Finally, in step 5 of designing sampling process, the researcher is to carefully execute the above processes to select or recruit samples from the population. A quick overview. We are now familiar with the terminologies used in sampling, learned the difference between population and sample, parameter and statistics, and we also have got a clarity and understanding of sampling, sampling error and sampling designing processes such as defining population, determining sampling frame, sampling techniques, sampling size calculation and executing sampling process. I duly acknowledge all the authors whose work I have referred for this lesson. Thank you.